Welcome everyone to our fraction series. Today we'll be looking at the JAMB aspect of it. Fractions are of the form A over B, where A is the numerator and B is the denominator. B must not be equals to 0. The basic rules of addition, subtraction, division and multiplication applies with fractions. If we are to perform more than one operation of the formation, then Bodmer's rule must be strictly followed, where B is for bracket, O is for off, D is for division, M is for multiplication, A is for addition, and lastly, S is for subtraction. Let's take some examples and see how we apply them. Simplify. At the denominator, you have 2 divided by 1 over 4 of 32. Then at the numerator, you have 1 whole number 1 over 2. Solution. First, we change mixed number to improper fraction and solve numerator and denominator differently. As is to say, our given problem become equals to 3 over 2 at the numerator divided by 2 divide 1 over 4 of 32. Applying Bodmer's at the denominator of first before division. So our given problem will become equals to 3 over 2 at the numerator over 2 divided by 8. What happened there? 1 over 4 of 32 gives you 8. That is 4 divide 32 will give you 8. Next, changing division to multiplication at the denominator, it will be equals to 3 over 2 divided by 2 times 1 over 8, which is equals to 3 over 2 over divided by 1 over 4. And that is the same as 3 over 2 divided by 1 over 4. We are expressing it properly. Changing from division to multiplication, we have our result will be 3 over 2 times 4 over 1. Our result will be equals to 3 times 2, which is the same as 6. Another example. Simplify 4 whole number 3 over 4 minus 6 whole number 1 over 4 divided at the denominator 4 whole number 1 over 5 of 1 whole number 1 over 4. The options are given. Solution. First, we change mixed numbers to improper fractions. Our given problem becomes 19 over 4 at the numerator minus 25 over 4, and at the denominator you have 21 over 5 of 5 over 4. Both numerator and denominator have only one sign. Thus, we solve them differently. As at the numerator you have 19 minus 25 over 4. Thus, we look for the LCM of both 4 and 4, which is 4. Then when 4 divide 4 is 1. 1 times 19 will remain as 19 minus. Then in the other fraction, 4 divide 4 is 1. 1 times 25, 25. Then at the denominator you have off is simply multiplication. So you have 21 over 4 because 5 and 5 will cancel out. And that will give us minus 6 over 4 divided by 24 divided by 21 over 4, which is better expressed as minus 6 over 4, then with your division sign proper, 21 over 4. Changing from division to multiplication, we now have our answer will be equals to minus 6 over 4 times 4 over 21. Sometimes we cancel out. The result will be minus 6 over 21. And that is the same as minus 2 over 7. Another example. Evaluate 1 over 3 divided by a bigger bracket open, 5 over 7. Then we have a smaller bracket, 9 over 10 minus 1 plus 3 over 4, bracket close. Then we'll close the bigger bracket. The options are given. Solution. Bodmer's rule says bracket first. Starting from the inner bracket, LCM of 10 and 4 is 20. So our given problem becomes equals to 1 over 3 divided bigger bracket open, 5 over 7 into the smaller bracket, and we now have at the numerator, we now have 18 minus 20 plus 15, all over 20, bracket close, then the bigger bracket is closed. What happened within the inner bracket? The LCM of 10 and 4, which we already said is 20. In the first case, 9 over 10. 10 we divide 20, and you have 2. 2 times 9 will give you 18. Minus, in the case of 1, it becomes 20 automatically, because 1 divided 20 is 20. 20 times 1 becomes 20. Plus, in the case of 4, at the denominator, 3 over 4. 4 we divide 20, and that is 5. 5 times 3 gives you 15. Hence, the result there at the numerator, all over 20. Now, the simple arithmetic operation will still take place within the inner bracket, and our result will become 1 over 3 divided by the bigger bracket open, 5 over 7, into the smaller bracket, become 13 over 20, bracket close, and then the bigger bracket also close. We just did our addition and subtraction there. Next, we should note that the two brackets inside implies multiplication. Our given problem becomes equals to 1 over 3 divided by bracket open 5 over 7 times 13 over 20. And once that multiplication is done, we will now have our result as 1 over 3 divided by 13 over 28. What just occurred is that within the bracket, some terms will cancel out, and that is why we have that result. Next, we change from division to multiplication, and that will be 1 over 3 times 28 over 13. That's same as 28 over 39. Another example. Simplify 1 plus 2 at the numerator, the first numerator. Then we have, under the denominator, we have 3 minus 4 over 5 plus 6 over 7. The options are given. Solution. We start from the last term operation. That is 5 plus 6 over 7, which is the same as, we just do our simple arithmetic operation there. So it will be 35 plus 6 over 7. 7 times 5 plus 6. And that will be equals to 41 over 7. Next, we take the next operation that follows, which will now become 3 minus 4 over 41 over 7, which is the same as 3 minus 4 divided by 41 over 7. By Bodmer's rule, division comes before minus. Thus, we change division to multiplication. And our result will be equals to 3 minus 4 times 7 over 41. Because once you are changing from division to multiplication, you invert, you change, you turn upside down. And that is why 41 over 7 became 7 over 41. And that will give us 3 minus 28 over 41. Because we just use the numerator to multiply out in this case, since nothing cancels out in the multiplication. Now, we can now perform our simple arithmetic operation, which will be equals to 123 minus 28 over 41. And that's equals to 95 over 41. Finally, we can now solve the last operation, which is 1 plus 2 over 95 over 41. And the result will be equals to 1 plus 2, then show your division sign properly, 95 over 41. By Bodmer's rule, division comes before minus. That is to say, we change division to multiplication here. And the result will be 1 plus 2 times 41 over 95. When we are changing from division to multiplication, we invert. That's why 95 over 41 became 41 over 95. Next, no term will cancel out, so we just multiply out. And that will be equals to 1 plus 82 over 95. From there, we do our simple arithmetic operation, and that will give us 95 plus 82 at the numerator all over 95. That will just multiply 95 times 1 plus 82 all over 95. And that will be equals to 177 over 95. Another example. Simplify 1 over 2 plus 1 In the denominator, you have 2 plus 1 over 2 minus 1 over 4 plus 1 over 5. The options are given. Solution. We start from the last term's operation. That is 4 plus 1 over 5, which is the same as 20 plus 1 over 5. You just multiply out 5 times 4 plus 1. 5 times 4 is 20 plus 1 over 5. And that's the same as 21 over 5. Next, we take the operation that follows, which is 2 minus 1 over our result, which is 21 over 5, which is the same as 2 minus 5 over 21, because 1 over anything is the reciprocal of that thing. Now we perform the next arithmetic operation, which will give us equals to 42 minus 5 over 21. What happened there? We just cross multiply 21 times 2, which is 42 minus 5 over 21, which will give us 37 over 21. Then we perform the operation that follows. Next, 2 plus 1 over 37 over 21, which is equals to 2 plus 21 over 37. The same thing applied here. 1 over anything is you invert. That is why 37 over 21 became 21 over 37. And when you do your simple arithmetic operation, it will be equals to 74 plus 21 over 37. What we have just done is we multiply at 37 times 2 plus 21 over 37, which is equals to 95 over 37. Finally, we perform the last operation, which is 1 over 2 plus 1 over 95 over 37, which is the same as 1 over 2 plus 37 over 95. Simple inversion. 1 over anything is that thing inverted, especially dealing with fraction. Next, we take the LCM of 2 and then 95, and that will give us 190. So 2 divide 190 is 95. So 95 times 1, that's why you have 95 at the numerator, plus 95 divide 190 times 37, the value times 37 will give you 74. When you perform the simple arithmetic operation, it becomes 169 over 190. Next, we take word problems involving fractions. Here, the pattern is careful interpretation of the statements made into the appropriate fractions. Then we solve as it is done in fractional operations. Let's take our first example. 3 teachers shared a pack of chalk. The first teacher got 2 over 5 of the chalk, and the second teacher received 2 over 15 of the remainder. What fraction did the third teacher receive? The options are given. Solution. Let the whole pack of chalk be x. First teacher got 2 over 5 of x. Second teacher got 2 over 15 of x minus 2 over 5 of x, bracket close. Third teacher got x minus, bracket open, big bracket, 2 over 5 of x plus 2 over 15 of, bracket open, x minus 2 over 5 of x, bracket close, then big bracket is closed, which is the same as x minus, bracket open, 2 over 5 of x plus 2 over 15. We are solving the first inner bracket and we'll be left 3x over 5 there, bracket close, then before the bigger bracket. What actually happened is the inner bracket x minus 2 over 5x will give you 3x over 5. Then the result follows as when you multiply out the term before the bracket, 2 over 15 into the bracket, you will now have x minus, bracket open, 2 over 5x plus 2x over 25, bracket close. Next, in the inner bracket now, you now have simple arithmetic operation of addition there. And when you do that, it will be x minus, bracket open, 10x plus 2x over 25, bracket close. The LCM of 5 and 25 is 25. So when 5 divides 25, it gives you 5. 5 times 2 give you 10. Then in the other fraction, 25 divided 25 is 1. 1 times 2 give you 2. That's the result. Next, we now have our result as equals to x minus 12x over 25. which is the same as 25x minus 12x over 25. We just simply did our arithmetic operation, 25 times x minus 12x. And that's the same as 13x over 25, which is 13 over 25 of the whole pack of chalk. Another example, a man spent 2 over 5 of his monthly salary on feeding and 1 over 3 of the remainder on school fees. If his balance amounted to 14,000, find the total monthly emolument. The options are given. Solution. Let the total monthly monument be x. It follows that feeding, which is 2 over 5 of x, and by that implication, remainder is x minus 2 over 5 of x. And since the school fees is 1 over 3rd of the remainder, which should be 1 over 3 of x minus 2 over 5x, we are told that the balance amounted to 14,000, which is to say x minus 2 over 5 of x minus bracket open 1 over 3 of bracket open smaller bracket 3 over 5 of x bracket close is equals to 14,000. That's after all the deduction from the whole salary. The whole salary is x, give you 14,000. Now, solving from the inner bracket, our result will be x minus 2 over 5 of x minus 1 over 5 of x equals to 14,000. To clear fraction, multiply through by LCM, and the LCM here is 5. So we now have 5x minus 2x minus s equals to 14,000 times 5. And that will give us 2s equals to 14,000 times 5. Next, to make s the subject formula, the result will be 2x over 2 will be equals to 14,000 times 5 over 2. X would be equals to 35,000. We've come to the end of the teaching under this fraction session. Next, we have some exercises taken from page 2, 3, and 5 of the hidden fact in JAMB mathematics. I will advise you try your hands on the exercises. The answers are given at the answer section of the book, either the hard copy or the soft copy. Thank you.